Welcome back, MEFB 2132013 manufacturing processes class. Okay, let's look at the next chapter, process automation. So this is another level of manufacturing. Yeah, so all this while we were talking about the normal manufacturing, where you manufacture products using manual operation. Okay, and now we are talking about automation. And when you talk about process automation, we are actually automating the plant minus human. So we don't have this technology in Malaysia. We have partial, yeah, where some of the work is done by robots and all. If you go to Proton, you'll find that some of the painting, welding works is done by robots, but then it's not fully automated, and we do not have a fully automated plant in Malaysia. There is probably that one, some that exists in overseas, but you must remember that for you to automate the entire plant, there are several issues involved. Number one, obviously your production will be superb because it is automatically controlled, no human intervention, therefore no accidents. But in terms of ethics, a lot of people will lose jobs. Yeah, they won't have a job because of this action, and it's a very costly affair. So let's look at process automation. Yeah. So, computer and electronic communication developments have led to the improvement of manufacturing process efficiency, and this development also has led to computer integrated manufacturing. So, if you see in this chapter, we have for you to automate a plant, you need to have three features: simulation, automation, robots. Okay, so all these three elements must be present in order for you to automate a plant. So what is simulation? Simulation is basically an act. If you remember, in the last chapter we did programming G code and N code, and once you have finished programming, you want to simulate the object to see how it will function, right? And if there's something keyed in wrongly, it will show or indicate in the simulation that's an error. So that's the whole idea of simulation. You want to simulate to see how your product will look like at the end, and if all the dimensions that you have keyed in is accurate, because this simulated or this program will be connected to the robots or the automated machines to carry out the task. Okay, so then you have automation. What is automation? Automation involves automatic handling between machines. So automatically each machines will coordinate with each other, and there'll be a robot. So say that if the process flow involves 9 machines, the product from raw material have to pass through 9 machines. So the machines, each of the machines will be programmed beforehand. And if you see, there will be a robot that will pick the object and place in machine 1 and press the start button. Once the operation is done, it will remove the part, place it on the conveyor belt, and it will be transported to the next machine. The next machine, there will be another robot waiting. It will pick the object, place it in the second machine, and push the start button for the second process to take place. And once it's done, the robot will take it and place it back into the conveyor belt, and the conveyor belt will move to the third machine, fourth machine, and it will be a continuous process on and on. So if you only consider a system automated when they are mechanically joined for continuous automatic handling and processing. Example, an automatic lathe machine that is joined to a robot to load and unload parts from and to a conveyor. The moment human intervention is present, then it's not considered automated anymore. Why do you want to automate? Number one, you can reduce direct labor costs. Okay, so when you automate, robots are doing the job. So conveyor belts, automated guided vehicles are doing the job. So you do not need to pay workers' salary. So you can save on the labor costs, yeah. And you will definitely get uniform quality, because when operators are involved, sometimes human nature, yeah, they tend to make mistakes. They tend to become lazy. They tend to become tired. They stop, waste time. They chit chat. And then suddenly they, due to not, sometimes when they don't focus, they may make errors during the production. So all this can be avoided when it is being automated, because robots will not make mistake. Yeah, safety, there will be less accidents. So when humans are tired, They tend to like they tend to make mistakes. They tend to accidentally slip off. They may accidentally put their hand into the machine, injuries, yeah, which this will not happen when robots are involved. So when robots are used, everything is pre-programmed. So they have already the defined parts and they can move accordingly. Therefore, the shop efficiency is improved. There won't be any like so-called kelam kabut situation, yeah. The shop efficiency is improved and automatic distribution of parts during loading, unloading and inspection. And lastly, use of standard tools instead of specifically designed tools, okay. So lastly, robots. What are robots? Robot is a reprogrammable. So if you look at it, like this is an automation. So if a robot, it will pick and place the object to the next level, yeah. So the robot will pick and place the object to the next machine, and it will go on, so on and on, yeah. What is robot? Robots is a reprogrammable multifunctional manipulator designed to move materials, parts or tools through variable programmable motions for the performance of variety of tasks. So robots are used in light and heavy manufacturing, foundry, automotive, electrical and aerospace industries. Typical jobs for robots. Robots can do spraying, grinding, deburring, welding, packaging, searching, loading, unloading and tool positioning. So this is an example of a robot, okay, that is being programmed to do a certain task. Okay, so what is a robot made of? A robot is made out of a manipulator or a mainframe, wrist and effector. Controller is the brain of the robot. So controller is your control program, yeah. Control program, like I told you, we did it in the last chapter. Control programs are, controllers are very expensive, yeah. So you can imagine in a robot, the controller level is going to be the control system used is going to be very high and sophisticated. So it is the brain of the robot. It stores data and direct movements, and the controller functions to initiate and terminate a motion of the manipulator in a desired sequence. It stores position and sequences data in the memory and in interfaces with other manufacturing operations. And then the third one is the power supply. So you have different types of robots. You have a manual manipulator, which is worked by an operator. So it's a very basic robot. Then you have a fixed sequence robot. Fixed sequence robot is a robot that will perform repetitive operations according to the predetermined pattern. So meaning that it has capability of only doing one sequence, okay. So that means it picks an object from A, places it in B. It cannot do anything more than that, okay. There are some robots that is multifunctional, but in this case, if fixed sequence, it can only do one motion at a time. So if you wanted to pick from A and place it in B, it will just keep doing that. Pick from A, place in B, A to B, A to B, A to B. Okay, then we have variable sequence robot. Variable sequence robot, in this case, the pattern of the motion may be changed. So the robot is able to do multiple sequences, yeah, or multiple tasks. Like it can first do some painting, and then it can you can make the robot go and do some packaging, and then it can come back and do the painting again. So that is a multiple sequence robot. Then you have a playback robot. Okay, playback robot is capable of storing information into its memory, and you can recall it anytime you want. So for example, if the robot is designated to do painting, it will do painting all day for the next 3 days, and then you want the same robot to go and do packaging. So it will be able to recall its program of packaging, and it will be able to perform the packaging operation. Okay, then you have intelligent robots. Intelligent robots has sensors for vision and touch. Okay, so intelligent robots behave like a human. Okay, so if you see, robotic sensors. It has got human-like capabilities. It has vision sensors. It can see. Tactile sensors can touch, and has voice sensors. Okay, so if there is a defect, like if there's a leakage, the robot will be able to detect it way long before a human can detect it. Yeah, so that is intelligent robots. Okay, so what is a flexible manufacturing system? Flexible manufacturing systems are arrangement of individual workstations, machining cells, and robots under the control of a computer. So workpieces are mounted on pallets which move through the system, transferred by conveyors. So again, there is flexibility in the process itself. You have conveyor belts to assist you. You have automated guided vehicles. Yeah, so that's called a flexible manufacturing system. It's not rigid like in the normal factories where the machines are already static there, and then the workers' movements are defined. Our workers' movements are unpredictable. Yeah, so we don't call that flexible because it can get messy at times, right? But when a flexible manufacturing system will involve all automated systems, and you have automated guided vehicles, robots whose path is already defined. Okay, so that's it from me. Thank you very much.